Our third and major technique here, and final major technique that we'll use in this topic, is using some of those known trig identities to rewrite functions. Let's take a look at the limit as x approaches 0 of 1 minus the cosine of x divided by 2 times sine squared of x. And just like when we have polynomials, sines and cosines are very well-behaved functions, so you should look and see what happens when you substitute 0 in. The cosine of 0 is 1, so this gives us 1 minus 1 in the numerator, which is 0. Sine of 0 is 0, and then when I square it, that's 0. Multiply it times 2, that's 0. So I end up once again with this indeterminate form of 0 divided by 0. And the trig identity that we want to use here is probably the major one to make sure you know, and that's the Pythagorean trig identity that says the sine squared of x plus the cosine squared of x is equal to 1. And what I want to do right now is I want to take the sine squared of x and I want to rewrite it using this identity. And just some very simple subtracting the cosine squared of x over gives me 1 minus the cosine squared of x. And so now I'm going to rewrite this function letting sine squared of x equal 1 minus cosine squared of x. Again, notice the limit notation is still there. The limit notation is going to be there until I actually evaluate the limit. So I still have 1 minus the cosine of x in the numerator. My denominator is 2 times 1 minus cosine squared of x. Well, the reason why that particular identity is helpful for us is because 1 minus cosine squared of x is actually going to be the difference of squares, 1 and cosine of x. So I can rewrite that, still with my 2, as 1 plus cosine of x and 1 minus the cosine of x. It's a very odd looking difference of squares, but it works, and it's going to accomplish this same idea. We're going to be able to divide out a common factor. And so now we have the limit as x approaches 0 of 1 divided by 2 times 1 plus the cosine of x. And again, whenever you get a common factor to divide out, you should try substitution again and see what you get. Well, 1 over 2 times, remember the cosine of 0 is 1, so this is 1 over 2 times 1 plus 1, which comes out to be 1 over 4. So these trig identities, and this is the one I would always tell students to make sure you know, is the Pythagorean identity. Sine squared plus cosine squared equals 1. Because so many things can be derived off of this identity. For example, in this one, we were able to just simply solve it for sine squared of x and use it to accomplish what we wanted here. So this would be the one I would tell you for sure to know, but there are some other identities that produce this same idea where it allows us to rewrite a trig function, divide off a common factor, and then try to evaluate the limit again, and this time producing a result.